Hi, my name is Travis. I'm a radiographer at TCH and I was meant to be taking the hands-on labs at UC. Unfortunately, because of COVID-19 and all the various quarantine measures in place, we are unable to do that. So instead, I'm going to do a video on something practical that you can do in your home, quite simply. What I'm going to try and do today is teach you the basics of how to get perfect circles on an II machine. Okay? Now, the reason you would need to do this in theatre is for tibial and femoral nails. What they're using a perfect circle on your II for is to see down the barrel of a tibial nail or femoral nail so that they can drill through cleanly without any issues. Now, in order to do this experiment, what you need is a point light source. While I was playing around working this out, I found that your phone is actually one of the better sources of light for this. Your phones have very small LEDs, which means that you've got a rather small focal point, which allows you to get a nice crisp image later on. Another thing you need is something small and cylindrical. So this is just tape. I realise not everybody has tape lying around. If you're anything like the rest of Australia, you probably have hoarded just a little bit of toilet paper. This works, promise. This is also useful for creating a circle beam of light, and we'll show you that in a minute as well. Okay. Next up, the setup. Alright, so in order to do this, dead easy, this is the floor. You place your light source down on the floor, switch it on. And we also have your roof. So your light source is going to be your X-ray tube. Your roof is your detector. So you'll notice here I've got a H and F, head, foot, A and P, anterior, posterior. And you don't need to mark your roof. This is just something I'm doing for demonstration purposes. As long as you know when you're doing it which direction is which, then you won't have to mark your roof. The other thing you need is a darkened room so you can actually see your light source. And it's a little difficult to see that there, so what I'm also going to do is to place that toilet roll there, and now I have a circular light field, which is exactly what you're going to see in theatre. Okay? Next step is to get your tube. In this case I'm using sticky tape, and then you can manipulate which direction, which orientation it's in. And your aim here is to orient it so that you get perfect circles. Now, I'm going to do this in more detail in a moment, using multiple fields of view so you can exactly see what's happening. But as I rotate this around, you'll see that the direction, the core of your object will change. And that is the crux of what we're going to learn today. Which directions change, what image will be viewed when you change in which direction. Okay? So, just for visual purposes, what I'm doing there is just rotating like that, and that's changing the light up there. So now I'll show you how it looks in multiple views. Okay, starting with the most basic of shots, staring straight down the middle of our test tube here. This is basically the aim of what we want to see. We've got this nice set of circles right down the middle there. And that's basically what you want to see with the surgeons using that as a guide for the drill. We'll get to the way that the circles change in a minute, but for now let's look what happens when we move between directions. So in this case, head end and foot end. I'm going to try not to rotate this tube. Let's see what happens. So let's stretch it out. So you can see, as I move from head to foot and vice versa, that our perfect circles no longer become perfect. And they start to shift off. Get back in that center. Just a little bit. Now the same will be true of the posterior-anterior rotations. Not rotations, shifting. So that already should show you how not being in the center will affect your shot. Basically what's happening here is that the circles become slightly less circular because you're no longer looking straight down the X-ray tube. Your diverging beams are causing you problems because your circles no longer will be over the top of each other with respect to the X-ray beam. So this forms the basis of finding perfect circles. We want our beam to go straight down the core of the tube, straight down the drill holes of the nail, so that the surgeon can orient themselves correctly with the drill. So let's look at a few basic examples of what happens when our tube, our tibial nail, is not correctly aligned. So we're going to start with easy one, rotating anterior posteriorly. So our closest to detector is going to move towards the anterior end. Closest to the X-ray beam is going to the posterior end. So notice how we create this sort of slit eye shape. Now, if I rotate in the other direction, the same thing is going to happen. So just like that, we can see there that the tube is becoming more of an eye. It's a little difficult to tell on these images, but if we had a much longer tube, we would be able to see that the circle closest to our detector, in this case the roof, will be much smaller than the circle closest to the X-ray tube. And this would be able to help us figure out which direction we have to turn our tube. Unfortunately, you're not going to get that kind of resolution, and even with this much thicker tube setup here, with these lights much further away than what you would have on a regular II detector, you will not be able to see this. So it is a guess as to which direction you need to go, but you can look at the anatomy of the patient in the orientation that the surgeon has them, and you will be able to work out which direction you need to go. Now, the same thing will be true if your tube is rotated in the head-foot craniocaudal direction. So let's show you how that works. Something a bit like that. Again, you get that eye thing happening. In this case, I've rotated the head of the tube closest to detector towards the head end, and now we'll show you that the same thing is possible in the other direction. So now our foot end is the closest to our detector. Okay, so that covers the simple cases when you're out in only one plane. But what happens when you are out in both planes at once? Let's show this by moving the circle closest to the detector, this one here at the top, the detector being the roof. Let's see what happens when we move that towards the head end and anterior end at the same time. So, rotating towards the head and also rotating towards anterior. So, You see there that we now have this sort of eye slit. With this eye slit, when your circles become diagonal slits, you know that you're out in multiple planes, okay? And that means you have to correct it in multiple directions. So one of the better ways of doing this, particularly if you're a beginner, is to correct in one plane at a time. So for this one, we are going to correct in the anterior-posterior direction, okay? So, rotating around, you can see that we're opening up, and then suddenly we're reversing that slit, okay? That is telling you that we're going in the wrong direction. We've gone too far, okay? So let's go back to that one there. Now you should be able to see that we have a straight line, more or less, from posterior to anterior. That means that you have corrected the slit in that orientation. When the diagonal slit becomes a straight line in one direction, you have corrected it in that direction, in that rotation, okay? So then, what we have to do is correct it in the head-foot direction, which is like that. So we have now corrected it back into both planes, so we are looking straight down the barrel again. Okay, so let's go back to that original orientation, head and anterior. The other anterior. Head. Excellent. Okay, so there is another way that you can get that diagonal slit. If you want to take a guess, go for it. The other way is if we move our top end again into the opposite direction. So we're going to rotate to posterior foot. So notice the diagonal goes in that direction. We're going to posterior foot orientation, which looks basically identical. Okay? So how do you know which directions you're out in? Rotate in a direction and find out. Because if you keep going worse in one way, you'll know that you are incorrect and so must turn back. Okay? So let's go for the other direction now and show you that this is easy enough to do in both ways. So we've already done the head anterior or posterior foot direction. Let's go into posterior head. So going posterior head. Remember, we're orienting towards what our side closest to detector is. So we are now, I have done that into the anterior direction. I'm bright and intelligent, I promise. So, posterior head. Let's get that back to center. Okay. Let's correct this time for the head-foot direction first. So to do that, notice how our head-foot direction is now basically centered and we've overshot. Come back up, and we're basically aligned there, but we are, that's still a little bit terrible. And now we are more or less aligned in that orientation. We're not perfect, but we've got a lot. We're much better than what we were. And now let's roll backwards AP. So rolling. And you can see that we're slightly out still, but it's not that bad. A surgeon will probably accept that sort of circle there. So again, we've gone head posterior with our side closest to detector. So if we move that into anterior foot direction, we get that same slit. Anterior foot. Ooh. Posterior head. Cool. So that's the basic lesson for today. You can do one thing more advanced, and I'll show you that in a minute. It's a little more complex to set up. You will still need a detector. In this case it will be my wall. You'll still need your light source, which will still be my phone. What you will need to do though is to tape your simulated drill holes, tape that to a long object such as a fork. Make sure it's not in a flat plane. You want to be able to manipulate in multiple directions over the course of the simulation. Then place it in between or on a table and just make sure that it's counterbalanced by some heavy books, board games, something like that. Make sure you know which end is your head end and your foot end. Again, anterior, posterior. And this is the quick setup simulation that you can do for that. Okay, so with my setup here, again we have anterior, posterior, head and foot end. So what we're aiming to do here is I have set up the tube again, and we've got to figure out how to move our X-ray device, in this case our light, in such a manner as to make perfect circles up on our detector, which is our wall. So what we're going to do here is we start flat, more or less aligned to you guys. So we can see in this orientation that our drill holes are oriented so that the side closest to detector, which is the wall, is either pointing anterior head or posterior foot. Now, if this was inside a person, you would not know which it is, so you would start to move. The way I normally do it is to move the head-foot side first because that's the most difficult. So, you will know if you're going wrong if this happens. The slit formed by the drill holes becomes smaller, so you know you need to move in the opposite direction. And then we've gone past where we need to be. So let's get our X-ray tube back into the middle. So our X-ray source is now pointed correctly in the head-foot end because the slit is aligned in that direction. It's the 2 points in the slit are in the head-foot plane. So now we need to figure out if we need to go roll up or down, anterior or posterior. Now, we know that we've just moved our X-ray tube to the foot end, which means the detector was at the head end, and we've correctly oriented it in that direction. So we now know that we need our detector to be rolled anteriorly, which means our X-ray source needs to go down in the posterior direction. And there you have, more or less, a couple of fine-tuned adjustments, a perfect circle using with that orientation of the drill holes. From this point on, a surgeon would line up their drill and point straight down the tube and drill. Again, not ideal to not be in person to show you this on an actual II machine, but hopefully this little exercise will have helped you figure out how to orient or to visualize what you need to orient in the middle of a theatre case. Hopefully there'll be another video come up where I do show you on an II machine itself what you're actually looking at and how to reorient your tube. For the meantime, I hope it's all going well for you. Good luck out there. Thanks.